Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at health in the environment, monochloramine, and disinfection products, Dbps, in drinking water. What are some of the bad byproducts that happen, and how can they affect you? So drinking water drawn from surface water, such as Lake Champlain, must be disinfected to kill bacteria, viruses, and other organisms that can cause serious sickness and death. You don't want to get anything like amoebas, you don't want legionnaires, you don't want things like E. coli. Those can be very harmful. So there's ways to disinfect them. But are there some bad byproducts that come with that? The EPA requires public water systems use chlorine at a specific level for primary disinfection at water treatment facilities, and secondary disinfection is also required to treat any type of contamination that could happen after the water leaves the treatment plant. The EPA approves disinfectants for use as a secondary disinfectant: chlorine, chlorine dioxide, and monochloramine. So monochloramine is a chemical that is made by combining chlorine with ammonia. Although it's weaker disinfectant than chlorine, monochloramine is stable, remains effective in the water system over long distances for a longer period of time. Also, monochloramine has been used in the U.S. as a secondary disinfectant since the 1930s, and while the EPA does not know the absolute number of people using water treated with monochloramine, it's estimated that the number exceeds 68 million were identified in a 1998 survey. Now, are there some issues with it? There are some byproducts. Most public water systems use disinfectant to kill viruses and bacteria that can cause sickness, such as gastrointestinal disorders or diarrhea. And chlorine is the most commonly used disinfectant, sometimes used in combination with other disinfectants, such as ozone, chloramine, chlorine dioxide, and ultraviolet light, or UV light. And disinfection byproducts, known as Dbps, are a family of chemicals formed when disinfectants react with natural occurring organic matter and other substances in the source water. The level of Dbps depends upon the nature of the source water, the type of treatment to remove particles and organic matter, and the type of concentration of disinfectant. The risk of illness from Dbps is much lower than the risk of illness from drinking surface water and some groundwater sources that have not been disinfected. The major risks from Dbps result from long-term exposures. Surface water sources such as reservoirs and streams are more likely to have DPV levels than disinfected groundwater sources. If you get your drinking water from private drinking well water, DPVs are likely to be present there. But the EPA rules require that water systems to improve treatment methods minimize the form of Dbps. So we have things like haloacetic acids, HAA5, and these are in drinking water when naturally occurring organic material in water reacts with chlorine or chloramine to disinfect the water, and consuming water containing haloacetic acids in the excess of maximum containment levels over many years may increase the risk of cancer. So there are some bad byproducts, and the current MCL, maximum containment, for HAA5 is 60 micrograms per liter. We also have total triethylamines, or TTHM, and these are in drinking water occurring when water reacts with chlorine or chloramine to disinfect water, and consuming drinking water with TTHM in the excess of maximum containment level over many years may lead to increased risk for liver, kidney, and central nervous system problems, as well as a risk for cancer, and the current MCL for TTHM is 80 micrograms per liter, or 80 parts per billion. So we can see there's some harmful byproducts as well. That's why it's always a good idea to periodically test your water.